Assalamu alaikum. I am Muhammad Jahangir Alam, lecturer in physics from Milestone College. First of all, thanks to Almighty that He has given me the ability to take this class. Dear students, I am still okay and carrying on my regular activities in this worldwide earth situation of COVID-19. So thanks to Almighty again. I also hope all of you are keeping safe yourself, remaining at home and maintaining the rules and regulation prescribed by the specialist. Right. Dear students, today we will discuss some important creative questions from our 6th chapter, that is the chapter of effect of heat on matter, and I hope this creative question will help you a lot for your upcoming exam. Okay, right. Dear students, this is our first creative question. According to the stream of this question, they describe that the distance between two electric poles is 50 meter. Here the distance between two electric poles is 50 meter and they are connected by a copper wire of 50.033 meter. The length of the wire by which the two poles are connected is 50.033 meter at 30 degree Celsius. When the temperature was 30 degrees Celsius, then the length of the wire was 50.033 meter. In winter, the temperature falls to 5 degree. That means the situation described above is about summer, and in winter the temperature falls to 5 degree. This is the final temperature. Mass of the wire is 30 kg. This is the mass of the wire and specific heat of the copper. That means materials of the wire. The wire is made of copper and the specific heat of the copper is 40 joule per 400 joule per kg per Kelvin. So this is our stream, and the questions are: what is freezing point? How does a bird fly at night? Calculate the radiated heat by the wire in winter. And finally, is there any possibility of tearing the wire in winter? Explain mathematically. Listen, this is our question. Now we are going to solve the questions. In first question, they said what is freezing point? Freezing point is actually a special temperature. The temperature at which a liquid start to convert into solid form is known as freezing point related to the liquid. Okay, so now we are going to see the definition of freezing. Right. According to the definition of freezing point, the temperature at which a liquid start to converts into its solid state is known as its freezing point. As per example, the freezing point of water is 0 degree Celsius. We know at 0 degree Celsius water start to convert into ice. So freezing point for water is 0 degree Celsius. Okay. Now we are going to solve our second question, that is, how does a bird fly at night? Though the question is not related to this chapter, that is the chapter of effect of heat on substance or matter. It's from the chapter of waves and sound. We know at night a bat cannot see anything, but it creates ultrasonic sound and it has ability to receive or hear ultrasonic sound. At night when bat moves, it creates ultrasonic sound, and if there are any obstacle in front of the bat, the ultrasonic sound created by the bat is reflected back. and the bat can hear the echo, and hearing the echo it can realize what type of obstacle is in front of it, then it changes its direction. Okay, so using ultrasonic sound and hearing its echo, a bat can fly at night. Okay. Now we are going to our mathematical problems. So here we have to calculate the radiated heat by the wire in winter. In summer, the temperature of the wire was 30 degrees Celsius, but in winter the temperature falls to 5 degrees Celsius. So obviously a certain amount of heat will be radiated by the wire. So we have to calculate what is the radiated heat. To calculate this, first we have to write which information are given to calculate this. Here mass of the wire is 30 kg. Mass M is equal to 30 kg. Specific heat of the material of the wire is specific heat denoted by S. S is equal to 400 joule per kg per Kelvin, and change in temperature. The initial temperature was 30 degrees Celsius and finally it falls to 5 degrees Celsius. So change in temperature del theta is equal to 30 minus 5 degrees Celsius, that is 25 degrees Celsius. Here the difference in Celsius scale, but we know in SI system the unit of temperature is Kelvin, and also we know the difference of temperature is same in Celsius scale and in Kelvin scale. So in Kelvin scale the difference will be 25 Kelvin. So we have to calculate it radiated heat. We know radiated heat Q is equal to ms del theta, right? So putting the value of the quantities, m means 30 kg multiplied by S means specific heat 400 joule per kg per Kelvin multiplied by change in temperature, that is 25 Kelvin. Okay, dear student, after the final calculation we will get 3 into 10 to the power 5 joule, right? This is our final answer for question C, that is the radiated heat by the wire in winter season. Okay. Now we are going to solve our last question. In the question they said that, is there any possibility of tearing the wire in winter? Explain mathematically. So we have to give an mathematical explanation that whether the wire will be tear or not in winter. To answer this question, first we have to calculate the final length of the wire in winter. If the final length, obviously we know in winter the length of the wire will be contracted, and if the final length of the wire is less than the distance between the two poles, that is less than 50 meter, then the wire will be tear. But if the length, that is final length of the wire, remain equal to 50 degree or more than 50 degree, then it will not tear. So first we have to calculate the change in length, that is the contraction in length of the wire, and then we will be able to get the final length, right? To calculate the change in length or contraction in length, we have to write the initial length of the wire, initial length, if denoted by L1, is equal to 50.033 meter, and change in temperature del theta already we have calculated in our previous math, that is 25 Kelvin. Okay, here we know to calculate the change in length we require a quantity which is known as coefficient of linear expansion, though that is not given in the STEAM, but we know the value of coefficient of linear expansion, which is denoted by alpha, alpha is equal to 1.67 into 10 to the power minus 6 per Kelvin. We write it from our memory. Now we are going to solve the change in length. Okay, we know the change in length, which is denoted by del L. Del L is equal to alpha L1 del theta, right? Here alpha is 1.67 10 to the power minus 6 per Kelvin multiplied by L1. L1 means 50.033 meter multiplied by, and change in temperature is 25 Kelvin, and after the calculation we will get 2.08 into 10 to the power minus 3 meter. That is, this amount of length will be contracted from the initial length. So now we have to calculate the final length, and then we give the final decision whether the wire will tear or not. So final length L2 is equal to L1 minus del L. Here L1 means 50.033 minus 2.08 into 10 to the power minus 3 meter, right? And after the calculation we will get 50.03 meter. So this will be the length of the wire in winter season. So observing the length, we can say that the length is more than the distance between the two poles. So the wire will not tear in winter. So therefore the wire will not tear in winter, right? I hope you understood it. This is our second creative question, and the question is from Rashtriya Board 2017 board exam. And in the stream of the question, there is a metal sheet having dimension 4000 millimeter, which is length, and 3000 millimeter, which is breadth. This is a metal sheet, and in the information they said that the area of the figure, that means surface area of the sheet, is increased by 0.1 meter square for the rise of temperature by 30 degree Celsius. The existing area increases by 0.1 meter square due to the change in temperature of 30 degree Celsius. These are the information. Our first question is, what is resolution? Second question is, explain the plasma state of matter. And question C said that find the coefficient of linear expansion of the sheet. Okay, dear students, we have no sufficient space to write the question D. We will write that after solving this. Right? Now we are going to solve these three questions. What is resolution? Actually, this is a process. Okay. Now we are going to see the definition of resolution. According to the definition of resolution, the statement is the process of melting a solid to its liquid state by applying pressure and then refreezing it by reducing pressure is called resolution. That is, first we have to apply pressure to melt a substance from solid state to liquid state, then we will reform it to the solid state reducing pressure. This process is known as resolution. Okay, now we are going to solve our next question. Explain plasma state of matter. Dear students, we know from our general concept we know there are three states of matter, and the states are solid, liquid and gas. But there is also another state of matter which is known as fourth state of matter. This fourth state of matter is known as plasma state. Actually, plasma state of matter remain in ionized gas at very high temperature. It is an ionized gas, so it can carry or conduct electricity. Plasma state formed at 5000 degrees Celsius temperature. Right? The main source of plasma is our sun. Now we are going to solve the mathematical problem, that is according to question C, find the coefficient of linear expansion of the material of the sheet. To find this, we have to first write the quantities which are given. Here the length and breadth of the sheet is given, from which we can calculate the area of the sheet. So initial area A1 is equal to length multiplied by breadth, that is 4000 millimeter multiplied by 3000 millimeter. We have to convert the value into SI unit, that is into meter unit. So it will be 4 meter and it will be 3 meter, and after the calculation we will get 12 meter square. This is the initial area of this sheet, and the change in area of the sheet is 0.1 meter square. So we can write change in area denoted by del A. Del is equal to 0.1 meter square. Change in temperature del theta. Del theta is equal to 30 degrees Celsius or 30 Kelvin. So from this information we can first calculate the coefficient of superficial expansion, then we will calculate the coefficient of linear expansion. Right? We know coefficient of superficial expansion beta is equal to del A divided by A1 del theta, right? Using the value del A means 0.1 meter square, A1 12 meter square, and del theta means 30 Kelvin. Dear student, after the calculation we will get 2.78 into 10 to the power minus 4 per Kelvin. This is the value of beta, but we have to calculate the coefficient of linear expansion, that is alpha. Again we know alpha is equal to beta divided by 2, that is 2.78 10 to the power minus 4 per Kelvin divided by 2, and the final result will be 1.39 into 10 to the power minus 4 Kelvin. So this is the final result for question C, that is this is the coefficient of linear expansion for the sheet, right? Now we are going to see our last question, then we will solve it. Dear students, our final question is, what will be the rise in temperature to increase the area of the sheet by 6%? So we have to show what will be the required rise in temperature to increase the surface area of the sheet by 6%. And this calculation is almost same to the previous calculation. Here the initial area A1 already we have calculated in our previous calculation, and that was 12 meter square. We have to increase the area of the sheet by 6%, right? So change in area, which is denoted by del A. Del A is equal to 6% of 12 meter square, right? And after the calculation we will get 0.72 meter square, right? Coefficient of superficial expansion beta also calculated in our previous calculation. We found that was 2.78 into 10 inverse minus 4 Kelvin. Now we have to calculate the required change in temperature. We know beta is equal to del A divided by A1 del theta. So we have to calculate the value of del theta, or del theta is equal to del A divided by A1 multiplied by beta. So using the value del A means 0.72 meter square, A1 means 12 meter square multiplied by beta means 2.78 into 10 to the power minus 4 per Kelvin, right? And after the final calculation we will get 215.83 Kelvin. So this is our final result for question D. Dear students, I hope you got the solution of the creative question. We have already told that these questions are very important for your upcoming exam. So I hope you will practice this type of question at your home. Thank you very much being with me in my class. May Allah bless all of you. Assalamu alaikum.